Hello, welcome back to BLENDERSUSHI Live Noding. In this episode, we're gonna take a look at the new updated nodes to Vector Evaluate. It's called the Vector Lerp, L-E-R-P. I think it stands for Linear Interpolation. Yeah, let's just have a look. It should be pretty familiar, but it's an improved version of Vector Evaluate. SV Lerp. So let's have a look. What's different now? Lerp. Vector Lerp. We still have the old evaluate, but I think I'm gonna use Lerp from now on. You can basically, let's say you have like a line and viewer draw. Let's say you have like 10 points of line, and then you kind of move the line in which directions? Y, maybe Y. So you have something like that. Y, 5 units in Y. So you have, at this point you have like basically you can have two objects if you bake it. But this is just a preview. Now, if we plug the before and after, this is the after, this is the before, and get the output. See, this guy is gonna move from original position into the target position. That you should probably already familiar, and I might have show you something like this before. I think evaluate is kind of doing the same thing with Lerp. What's the difference here? Let's try range math. Let's try math, and then range float. Let's have like a multiple time. Use math, so time going in, and then addition with this range float. So that's gonna give an offset to the time. I'll show you with the stethoscope what's going on. So we have 1, 2, 3. We have now 10 different time. So now let's have a look. I think it's happening, but it's happening so quickly we can't see anything. I'm gonna increase the size of these points and give it a different color. Okay, so we have something there. Although they are kind of super fast now, I need to use this multiplier 0.002. Okay, so looks like it's still kind of moving too fast. Let's change this number. Do we have animation? I thought we should see some animation. 0 to 1. Seems like this guy is still kind of moving too fast. Okay, I'm gonna use map range. I'm gonna change the value like that. 0 to 1 becomes 0 to 10 or 0 to 25 or something. And now it's kind of moving up. Okay. And seems like this guy is also, the vector lerp seems to be kind of overshoot as well. So with a value that's kind of over, it goes beyond. Which is interesting. That's probably not the best way to show this. Let's try using something simpler like frame and sine wave. Time and sine. What's gonna happen now? It's gonna move. It actually overshoot to -1 and then go to 1 and come back to -1, back and forth. To be more correct, we need to map range here. -1 to 1 become 0 to maybe 5. Let's have a look. 5 gonna overshoot again. Kind of keep it simple. Okay, now that's slightly easier to understand. So in order to make it between this guy and this guy, we need to make sure that this vector value is between 0 and 1. Okay, 0 and 1 here. So cool. We can use math here and multiplier 0.2 perhaps, make it slower. Now it's kind of doing this back and forth thing. And if we use like addition and range float, we should get offset. And this offset can be of any value actually. And we get this design. Okay, that's pretty interesting, right? So if I'm not wrong, this vector lerp also works like with a 3D object. So in a way, I think vector lerp is like ShapeKeys, okay? Because but it's kind of deforming. Now we only have like edges to edges, so and then we are only animating the points. But what we have here actually, if we just plug in the edges information there, you're gonna get line. Okay, that's very important. I'm gonna save real quick, and then now instead of line here, what if I change it to circle? And with circle, we're not gonna move it, we're gonna scale it. Okay, where's the before and the after? This is the before, and the after is this guy. We're gonna scale it. And let's test it out. Okay, it seems to be doing something. You want to see the point before and after, we just have another viewer draw. So this is the before, this is the after. Oh, actually this guy, after. We can scale this guy. Now we have this kind of effect. Super simple. If you want to double the sine, I believe we just use a multiplier right here. Make it twice. Oh, actually, because of the clamping, we have this kind of effects. Very nice. Kind of like it stops. Kind of like hold. Alright, that's interesting. And Maybe if we double it here, it's gonna do the rotation twice or more time. Let me increase the time to 2500. See that kind of motion. Thought that was super interesting. Let's go. Let's make it back to normal here. I tried it. Let's try doing this differently. Maybe don't use clamping. Maybe double it here. Don't use clamp. I'm gonna increase the number of points. Looks like the number of points needs to match this count. So integer 24, like that. That's the offset. Now we have this kind of motion. Very interesting pattern. I can increase it more, and we have that. It's starting to look familiar. It's like I don't know. I think we've seen something similar, but it's much simpler to recreate now. That's probably we can increase more. See that looks super complicated, but it's actually very simple underneath. What's going on is really just point going back and forth, but it's kind of offset. And if I'm not wrong, this is actually just like if you go to circus and then look at the clown and playing with the balls, and this is how they actually do it, I reckon. So you can make it faster, slower. Looks like a bicycle kind of motion. But the clown is kind of doing it in such a way so the ball is kind of overlap. So it looks like something like that. Okay, that's interesting, but what if we do a little bit more here? Like you can try using noise or just randomize input vertices of the circle. Let's say if we're doing it here and kind of breaking all this organized circle, what's we gonna have? We have some kind of randomization there. We can also do it to the original point. So you don't need to see that, you don't need to see that. So now it's looking like that. Slightly more random. If you are using like noise, it's also kind of give you interesting pattern. Now that's kind of random, but see underneath it's really just points going from one side to another. If you're looking at this, and then you might think, okay, this looks like almost like a crowd simulations, like kind of like people playing game, or kind of like almost like a flocking animation. Let me try kind of offsetting, less offset. See, that's really interesting motion. And you can actually use the noise in this vector as well, for the vector. So let's try vector MK2. actually noise, vector noise MK2, just supply the vertices. Let me try using line. Goes into the vertices, and then the number of vertices should match this guy, and randomize it. Oops, this should go there. Scalar, let's just use math here. Add. See, even this is kind of a surprise. I didn't expect this to happen. That's like a sine wave, and this offset value, and we can add this guy on top. This is standard Perlin, and standard Perlin. Let's try Voronoi. This guy didn't do much unless we animate the line itself. So I'm gonna try that. Vector math, add vector in, and give it a frame. Try Perlin and trying to oh, okay. We can see that there's some kind of noise happening. I think I like it simpler. Turn on clamp. Vector noise. Clamp. I know. I think this should go there. This is sine multiplier. This is clamping on. So clamping off, clamping on. Yeah, well, at the if you're ever like doing nodes like this, after sometimes it gets a little bit confusing unless you kind of check what's going on, what's really going on here, using the stethoscope. Look at the number, and you can kind of tell, okay, why is this guy doing that? That's because of this number. Still, without the clamping, it looks so chaotic now. Maybe I'll reduce this number, make it a bit slower. I think the number is a little bit too big here. Okay, that's interesting. It's get a little bit unpredictable, but however, now we are back to almost a little bit more controllable. Okay, so it's doing this back and forth motion. Remember, it's only like two circles. One circle is just with a little bit of randomness, the other one is more random. If I make this becoming less random, we can tell what's going on. If I only have like 3 points, yeah, it's almost kind of there, like doing this like a dance. See, it's moving to that guy. It's very interesting. In fact, if I turn on the edges and plug that into that guy, what's we gonna see? It's almost like they change place or something, kind of shifting. Oh well, I think I like it like a before. Now it's getting a little bit too complicated. But like I said, the idea is really with this Lerp, I think you can do like a ShapeKeys kind of idea. You have the original mesh and then the target mesh, and you can kind of um, blend between the two. Now it's this guy is kind of crawling from one shape to another shape. Really, if we just simplify it, see this guy just slowly crawling into the smaller circle. Let's kind of go back. Maybe the clamping is need to be less and more here. Zero to one. Seems like it's never hitting like totally zero. It's always like in motion. Maybe because of this guy. What if I zero that out? Increase the time. It's now starting to do that like a weird kind of motion. Okay, we're getting this again, like a flower. Yeah, even that I found that's kind of interesting, weird. Now climb off, and we have this flowery kind of motion again, with slight noise, so that's more natural. It's kind of like a dance, like human holding hand and then doing this kind of dance, and it creates this flower kind of motion. It's probably just a sine wave. Add a little bit of randomness. Okay, yeah, I think I quite like this. Yeah, I think this is nice, like this. Don't want to do too much. Make this 8. You guys can move here. Okay, yeah, so yeah, that's pretty much it. This is for Vector Linear Interpolation or Vector Lerp nodes. So this guy is responsible for it, Vector Lerp, and then this actually can work with a multiple objects. If we have multiple circle here instead of one, you can have quite interesting motion. Yeah, just give it a try. Start from nothing and think about origin, point origin and point ends, and then how you want to transition between those 2 points and have more points and have it like more points, and then see how you can control it using functions and whatever nodes SvechOp offer you, or you can do a little bit more, just make your own script node, whatever. Give it a try and you might come out with something that's interesting. Okay, yeah, that's pretty much it. If you have any questions, suggestion, let me know. Thanks again for tuning in, and I'll see you in the next video. Thank you.